going to test a new motor here. This 550 DC motor. The size of this DC motor is 550, and it has markings for the positive, then for the negative. Okay, and comparing it to the normal or other size of motor, this is 130. We also have 260, 365, 385, and we're going to use this 550. And the power from the battery. Then our test will include this tester to measure the current. Okay, let us now connect the positive to the positive of the battery. This is 12 volts battery. Okay, 12 volts battery. Then the other end is the tester connected in series. Since we're going to use the ampere, for the ampere, then set to DC. Okay, DC. And then the other end to the negative of the battery. We are having 0.9 ampere, 0.977. Oh, we cannot see. Let us see. 0.971, 70. That is the reading when the motor is has no load. 0.9 ampere using a 12 volts battery. We have 12.03 volts DC for the battery. Okay, without load. And when we connect the load, the motor, it drops to 11.87. Voltage drop at 11.87. And then, for the starting current, what is the starting current? 2.2, 3.4, 2.3. Around 3.3. Let us now test the stall current. Five volts. What? 5 ampere. 5 ampere. So when the motor is being stuck up, it can have 5 ampere of current. This is now our circuit, figure 1, motor circuit testing. So in our demo or testing, we're using a 12 volts battery. In series is the motor, and then in series is the tester. What is this letter A represents? That is ammeter. The tester is used as an ammeter or to measure the current. So in formality, it should be like this: ammeter A, the positive probe red, negative probe black, must be connected this way to the negative of the battery, and it is in series with the motor. So the conventional current flow is from to the right, clockwise. So in our testing, we have this motor. When we connect the supply, it will rotate the motor will run, and we measure the current of with no load. It means pure motor, just a pure motor, no load is involved. It's about 0.971 ampere, no load. Okay, and then when we the starting current, so the tendency of the motor is to start because of the because of the inrush current to the motor, it will kick or it will start sa a big current. Inrush current is 3.51 ampere. That is the starting current. And then for the stock up, whenever the motor has been jammed or stuck up, it is capable of rendering 5.1 ampere of current. So when the motor jams or jump, the current is 5.1. And then the voltage with no load, 12.03 volts of the battery. Well, during the operation, when the motor is running with load, the voltage of the battery drops into 11.87 volts. What I'm trying to say now is that this is the overall or the connection of the motor using a tester, and we measure the voltage of the battery connected here using another tester as a voltmeter. So we have two testers, positive to the positive, negative to the negative. It is in parallel with the supply whenever we measure a voltage supply. And then when measuring a current, tester must be connected in series. And so we have now these three parameters we got from the testing. We have no load current. It means the current, there's no, just a motor. Bare motor is used using a bare motor, and then is stuck up 5.1 or jump when the motor jump, and then starting current 3.51 ampere.